So we first wanted to go over our pseudocode and test cases from week 5. And so Marily's gonna, it's Marily, right? It's gonna
Yeah.
go over the gonna go over the first couple of points for us and defining the problem and the test matrix.
Yeah, so we're just going through the steps of defining the control layer. And so the first two steps are number one, to clearly define the problem. So our problem that we decided to work on as a team was to determine the weight to be added to the wagon and how much weight remains. So we put that there under task. And we needed to know what our inputs would be, which would be part of our function, item and weight remaining, what our output would be. We also defined some validation rules, what range we were using,
Yep.
and then we created some test matrices for matrices, I guess is the right way to say it, of how this function would work. So we have valid inputs, invalid, and some boundary test cases that we ran.
All right. So then we devised a solution, which Joseph is going to talk to us a little bit about. So go
All right.
for it.
So kind of our solution was, if the item weight is less than or equal to 0, that can't be right. Second part was, if the item quantity is less than 1, that also can't be right. And the third part was, if there isn't any weight remaining, there's no room, then you can't add to it. So that's an error as well. So this is helping us see what could go wrong in doing defensive programming.
And now Joseph's also going to go over the test cases for us in the table below. So we basically went through this with values.
All right, so what we would do is we did a variety of different numbers, just making sure what would happen that there wasn't any holes in any of the variables that we did. And that's why you go 7, just to make sure you're kind of like pushing it to see what happens if it goes wrong and what happens if it goes right.
So what we did the following week was we came into NetBeans and turned it into an actual use case. So this is our inventory control, where we're testing the calculator weight remaining. So in this case, we went through, similar to what Joseph was talking about, 7 different test cases, which we've commented in here, and gave it different values for each one. So I'll run through that. I won't press the play button because that would do the wrong thing. So inventory control test file, and we see down here test case 1, they all succeeded. So the -1 is that first error message that Joseph was talking about, and so -2 is another error message, and 3 is an error message. So it went through, tested the inputs, but those error messages were expected, and so it returned them, as we can see. So we ran through that test case to see if that was the case. Now, let's assume, because just now I made an oopsie and then had to fix it, if I did make an actual change and we wanted to push it to the repository, we'd come up here and go to git, and then commit, and then a window will come off screen apparently, and we can put in a description for it. In this case, fixed something, or I mean, obviously you would put something more meaningful than that, perhaps an exclamation and explanation on what has changed. In this case, we don't have anything to commit because nothing's changed. And after you've done that committing, you would go to git, remote, and pull before you push, because there might have been changes since you last did it. In our case, here's our thing. Next, the master file, finish, and so that is pulled. Nothing came along, so we were good enough to push. If something did come and there was a conflict, it would let us know and we could correct that. Now we push that back, so to the same place, next. And sometimes it deselects, but we can select it again there, next, and finish. So the file is now on the repository with the committed description as being the update note in the repository. We talked about a moment ago the pseudocode we did as a group and the test cases and matrices with that. So for my individual assignment, and we'll go over our individual assignments, for mine I worked on health and status duration. So this here is my pseudocode, which I've implemented into the code here. So this is my health control class. So as you can see here, if movement speed is less than 0, then, because movement speed can be 0, so it doesn't need to be less than or equal to, return -1s, because it can't be less than 0. If movement speed is greater than 3, return -2, etc. So these are the same test cases as were used in that individual assignment. So to test it, we went in and made a health control test class, which made a new object of that other one. So I called upon, I called upon those things. So just put those there for my own references, and so we did some tests on that one. So test number 1, and this was just for ease of, I guess, serialability. We printed out the test case number, which was that one, and +1 each time. Gave it a couple of random values of movement speed and hunger, and gave them smallpox. So in this case with an enum, we couldn't just use a number, so I had to actually write down what it was. And so that's the object. It's not creating a new object because it's referencing something that doesn't change. So we expected to get a -4 with 2 and 7, because 7 is too high for hunger. And so, and then it goes through health control, calculates the status duration with movement speed, which is 2, hunger, which is 7, and status, which is smallpox. And then we're expecting a result of -4. If that was true, we expressed, and if it wasn't, then we also expressed that. So went through a number of different test cases, and I'm going to show that real quick. Test, here we are, health control test. So if I test the file, on the bottom of the screen we should have test case succeeded. So we had a -4 was what we expected and returned, and for the other ones we had similar values. So that was the one I worked on. Next we had Joseph working on the charisma control.
So the charisma was determined on a couple of factors. One, we cited occupation, gender, and money. So what we were trying to do is, if their charisma was higher than a 20, then they would pass the speech check. And if it didn't, then they wouldn't pass the speech check. And so different things, for instance, like gender, if you're a male, it would add +5, and if you're female, it would add +10. And so you were just trying to come up kind of with an algorithm to get over 23, or see if it didn't.
Alright, so we'll go to the test case over here. So, yeah, I pulled it up, right, cool. So here's your test case.
And so in the test cases, we were just going over all the different occupations and basically seeing what would happen if you fiddle with the money and everything like that. And we got the results that we wanted.
Cool, so let's run that real quick. Charisma test, test file, and calculate test 1. So it looks like it ran through a number of situations and came out with a result.
Yep.
Alright, so up next we have the resource control.
Okay, so in the resource control class, what I decided to do was to base this calculation off of how hungry the player was, how many bullets they had, and also I wanted to include a random number that would kind of show whether or not what they chose, what animal they got to shoot. And so it would just, the calculation here that I worked out was that you'd have the number of items, so that is the number of bullets that they had, plus their hunger divided by the random number would give you a result. And that result would say what animal they shot, and each animal had a different weight and would give them more food for the game. So going on to the tests, I created 7 different test cases And so it calls on the calc hunting resource and includes the hunger, the item, and the random number. And the random numbers come from the matrices that I created for it. One thing that was interesting, after I created the 7 cases and ran through it, I did find that my last test case was different than what I had put in the matrix. And so I was able to see where that difference was, and I was able to change that. So that was kind of interesting. So if you could go ahead and run that for me, Steve, that
Absolutely.
would be great.
I had a moment there with the side thing. So testing the file, and there's our results at the bottom.
Yeah, so that last test case right there, number 9, I had written in my matrix that should have been an 8, and it came out 9. And so there was an error message there when I ran the test. I had to go back in and put in a different number, and so I could get it to run correctly. And so then it ended up working.
Cool. Alright, so we're going to talk a little bit about the scope and lifespan of variables. So we're using our main menu view program. So I'm going to be talking a little bit about this inputs variable, which is a string variable which is passed outside of the scope of this function. And Joseph's going to be talking about this other variable, and then Marilee is going to talk about the scope of those variables. So regarding this variable here, it comes from this function over here, so get inputs, and this variable is made for the purpose of passing back out to that get inputs. So, and it's through the process of this code turned into the input. So this one exists throughout this program and then is returned at the end there. And while the variable itself no longer exists, the value continues on and is used in the do action.
Yeah, and so the while in the do while is only specific to that do while loop. And while we have other while, obviously whys in the program, we only use it right then and there. And so it's kind of very local in that sense.
Mm-hmm. Yeah, so the kind of the difference between a lifespan and the scope is where you can use a variable. So like the y that Joseph was talking about can only be used there in that part of the program. It can't be used anywhere else. And that's the scope. The lifespan of that y is basically when it starts and when it ends and how long it's in the memory. So that's in the memory for a very short time. And the inputs that Steve was talking about, if you could highlight those for me. The scope of that one is a lot bigger because it starts there right at the beginning of the class and it can go all the way through to the end of the class. And so the lifespan is when it starts and when it ends. So that's the difference between those two.
So we've selected a couple of variables here which are passed into this argument, and we're going to be talking a little bit about them. So Joseph's going to be talking about the variables themselves. Marilee's going to be talking about how they're passed in, and I'll talk about what happens when they're passed in.
Alright, so we have a double just to begin, and that's going to be a pass by value. And then below that we have an object, and that's going to be passed by reference. And it's a good reminder is if it's a primitive, like an int, char, or kind of a long, then it's going to always be passed by value.
Mm-hmm. Okay, so our double there, our weight remaining is 30. And so because it's passed by value, it's just assigning 30 to weight remaining. And so it's actually transferring that information. It's passing that actual value to our argument, calc weight remaining. And the item, which is the object that's being passed, is just making a reference to a new inventory item that we created, a new instance of this object. And so it's just going to pass a reference to it. It's not going to actually pass the object itself.
Mm-hmm. And so what we can do after we've passed in those variables, so with weight remaining, I'll have to actually go to calc weight remaining, but basically we can use that value of 30, and it's always going to be 30 in this function. But item has a couple of things, as was said, assigned to it, so we're not just referencing one value, we're referencing anything that's attached to it. So it'd be item weight, quantity of items, or anything else that might be done with it. So when the function is performed, calculate weight remaining. But
I think just an inventory it's the inventory
here we are.
control.
Yes, here it is. So when those values are pulled in, this one's still a double, and this one is an inventory item. So it's an instance of inventory item, and so then we can do a bunch of tests based on those things. So with item, we can do various things like testing its item weight or quantity of items. So there's two different possible, or multiple different tests and things we can do with the values that come with that object. And when we assign something, if I was to say item weight equals 12, then it would change that value of 12 without me having to return that. Whereas if I was to return weight remaining, I would have to do return weight remaining. So that's the difference between passing by value and passing by reference. So I've got here my individual assignment. I've added a void main just to show that, just so we can work within this one. And I've got here some if statements, plenty of those, an if else, and then if else if statements. So the best place to show all of that, first I've got my switch statement, which is down here. This is taking the user input. Unfortunately for the map, I didn't have many user inputs. I just had, that's supposed to be I and Q, to go from either to the inventory or to go and quit out of the map. So it takes the input, and it comes into the switch statement, so this is the inputs, and based on whether inputs is I, it does this, or it does Q, it quits and returns to the main menu. So I'm hoping that will still demonstrate that I know how that works. So when it comes to if-else statements, so I've got down here, actually I've got a do while loop for the display menu, display map. So this one, it'll ask for an input, so do ask for an input while this is false. So it returns false when I have a valid input, and a valid input is something that works in these statements here. So return true in the case of this. So yeah. Now if-else statements, I've got here a very long one. So I made quite an elaborate little map thing. I had to try and figure it out for myself. And I thought, well, what if I had two for statements, for loops. This one's a for loop getting my x coordinate, and this one's for my y coordinate. So every time this gets to, this comes in, so this is my y and this is my x, sorry, I had it backwards. And so in here, I want to test for a number of things. So if I want to find out if that is where the character is, and I've got up here my characters symbolizing the characters. And if it is the character, I put a C, or I put the character C there, which I can change it up here so it's easier. If it's where Zion is, so Zion X and Zion Y, which I've specified up here, then put a Z. If it's a border, and I've got two different specifications, which I could have combined, I just like them separated for borders. So one's the Y equals length and height, 1 and height. So for the entire top row and for the entire bottom row. So one is for the length and one is for the height. And then the last one is T, which is just empty space. So let me run this real fast. So it turns into a map setting right there. So this if, else, etc. Statement continues on like that. So now you notice I have an else statement here. So I do have my if else right there. If I was to delete all of that, let me just do that real quick just so I can demonstrate that in this video. That that would still work. So let's compile that, run the file. Obviously there's no borders or anything, but that's an if else. So it's either where the player is or it's nothing. So obviously for the sake of what we're doing, it doesn't help much, but for the sake of demonstrating an if else statement, it demonstrates it. So that's that.
Alright, this if statement has a variable called input, and if it equals A, then the system will print out valid value entered, and valid will also equal true, ending the loop. And then there's a bunch of else if, depending on what else the input could be. So you're covering what the user could input, as well as going through the loop until they enter something valid. Here's a case switch statement where for each different case or user input, like M, O, F, the user will be able to, for instance, for case M, they'll show how much money they have. For case O, they'll have show oxen. And so you get all the user inputs and you make them each a separate case.
Okay, so I'm going to go through a couple of selection statements. This one right here is a do-while statement. So it performs this function while this is not true. So while the string inputs, this is a string, an array of strings called inputs. And if these inputs, and this is an if statement that's nested in this do-while statement. So if these inputs, the length of them is less than 1, or if the inputs, the uppercase inputs are equal to Q, then it will return. It will go back up here and it will do this until this is false. So if this, and when this is false, then it goes down here and it does this action right here. And it does that the whole time this is not true, this whole statement. So while this is false, this Boolean end of view value up here is false. So the next selection statement I'm going to do is an if-else ladder. It starts out by starting with an if, and in this case it's checking the string menu item, which is equal to the inputs uppercase. So if a user enters the letter B for their menu item, it will do this function, and it goes through. So if it doesn't, it goes from top to bottom. So if it doesn't find a B, it will go to the next, and if it doesn't find an I, it will go to the next, H and Q, and down here to the bottom. If it doesn't have any of these, this is kind of a default statement, this else statement here. So it will return this line, it'll print out this line that says invalid value, please try again. And then that's the end right there of the if statement. So that's how that if-else ladder works.